Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on EMC consideration. Okay, so for this video, firstly, I will explain what is actually wave impedance. Next, I will also explain the characteristics impedance. I'm going to highlight the key difference between these two impedance. In fact, these two impedance, wave impedance and characteristics impedance, they are actually the fundamental in order for us to understand EMC shielding. So therefore, this video, I need to start before we actually go into in-depth discussion on EMC shielding. Next, after that, I will share with you how can we actually calculate the characteristics impedance of a medium. Okay, for example, we always use a good conducting material as a EMC shield. Okay, so this video, I will share with you how can we actually calculate and obtain the characteristics impedance of the conducting material as a EMC shield. So basically, all this will be the objective of this video. Guys, if you're keen to know more about EMC consideration, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on EMC. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, okay, I'd like to urge you guys to help this channel by like this video. Guys, give me a few seconds. Help me press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Okay, let's quickly understand the free space. Okay, so basically, these are for the free space characteristics constant. Okay, so in order to compute the characteristics impedance and also the wave impedance, okay, we need to define the free space characteristics constant. So we have the permeability and also the dielectric constant. As for the conductivity, okay, we will reference as copper. Okay, so this will be the conductivity, okay, for the characteristics constant. Okay, so next, I will explain the key difference between wave impedance and the characteristics impedance. This formula actually I have explained earlier on, okay, but this is actually the wave impedance. Okay, from this equation, you can see that wave impedance is actually equals to electric field over magnetic field. Okay, so basically this is the calculation of wave impedance. Next, okay, I want to quickly go through what is actually the characteristics impedance. For example, we use this good conducting material as a EMC shield. How can we actually compute the characteristics impedance? Okay, so this is actually the equation to compute the characteristics impedance of the medium. Okay, so this equation you can easily find, okay, on a lot of textbook, okay, on microwave engineering. Okay, so I will go through a little bit more later on to discuss the key difference between these two equations. Okay, so why we need to so-called calculate the characteristics impedance of the medium that we actually use as a EMC shielding. Okay, so this is very important, okay, because okay, the characteristics impedance actually influence how EM wave actually interact with the material. Okay, so basically the EM wave hit the surface of the material. This is what we call the boundary. And this actually, the different types of material will have different so-called interactive with the EM wave. So therefore, all these are very important. Okay, so let's take a look. Okay, for example, okay, under this EMC shield, okay, so before I started, just want to highlight this. Okay, for EMC shield, there are actually three components. First one is absorption, reflection, and multiple reflection. Okay, so the first one is actually the impedance matching for reflection loss. Okay, so therefore we need to have a mismatch, okay, in order to have a reflection loss. Okay, so this is what we want to achieve. When an EM wave actually encounter a shielding material, part of it will be reflected off the surface and part of it will be able to penetrate through the shielding. The reflection loss actually depend on the mismatch between the wave impedance and also the characteristics impedance of the shielding material. Okay, so in short, the larger the difference between the wave impedance and characteristics impedance, the larger we have for refraction, and therefore it may be ideal for this case here. Okay, so if the impedance are mismatched, okay, more energy will be reflected, okay, which means that the higher the mismatch, more energy will be reflected, and hence this will be reducing the transmission loss. Next, okay, will be the wave impedance versus the shielding material impedance. Okay, so this is actually the shielding. Okay, so this is actually the wave impedance. Okay, let me explain this. Okay, so under near field, okay, it can be dominated by electric field or magnetic field. Okay, so let's take a look on this equation here. So this is actually the wave impedance, which is E over H, electric field over magnetic field. For example, under near field, if let's say it's actually dominated by electric field, okay, so what will happen? Okay, which means that this electric field will be a very big number. Okay, so this H magnetic field will be a very small number. So from here you can see that, okay, the wave impedance will be a big number because of big electric field. So therefore, if under near field, okay, which is dominated by electric field, most of the time the wave impedance will be a high impedance. You can say that it typically like almost 377 at a certain distance. Okay, so next, okay, under near field, let's say now instead of electric field is going to dominate by magnetic field, what will happen to this so-called wave impedance? So now the magnetic field is a significant number. This is very small. So you can see from here, if H magnetic field is a significant number, the wave impedance will be a very small number. So hence, if let's say under near field, which is dominated by magnetic field, okay, so therefore the wave impedance will be very, very small. In fact, many, many times smaller than 377 ohm. Okay, so basically this is actually the free space impedance. Okay, we will go a little bit more on this. The shielding material's characteristics impedance actually determines how well it actually attenuates away the field. Okay, so basically this is the shielding material. Okay, so basically this is an important role, okay, to actually for the reflection purpose, which we are going to take a close look over here. Okay, for example, okay, conductive material. Okay, so if we have a conductive material, which means that the impedance will be small, correct? Because this actually allow electricity current to flow. And hence, because of this, we know that we are going to have a low impedance. So therefore, okay, they are actually having a better shield against electric field. Okay, while high permeability material actually has a higher impedance. Okay, so this is actually the example here. So this is the equation here. So in short over here, if you can see this diagram here, a huge mismatch between wave impedance and the shield impedance. Okay, so this will encourage more reflection, and hence lesser thing will be able to penetrate through the shield, which may be ideal for this case here. Okay, so let's go to action number 3. Okay, so action number 3 is actually transmission line effect. Okay, so before I start on this transmission line effect, okay, for example, under low frequency, okay, the shielding being a good conductor, they will behave like a short circuit. However, at high frequency, the shielding structure, okay, although it is a good conductor, okay, so basically like cable, okay, they actually behave like a transmission line. Okay, so in short, okay, once you actually come into high frequency, okay, so any so-called short circuit, they potentially can behave like a transmission line at high frequency. This is what you want to say. The characteristics impedance of the medium, okay, so therefore will affect how wave propagate and also couple into the shield. Okay, so this is important. So therefore, proper shielding design must account for this in order to prevent resonant or re-radiation. Okay, so this we will further discuss later on. Okay, not on this video, okay, but on my next few video, we will do a so-called detailed discussion on this here. Item number 4, absorption loss and skin depth. Okay, the intrinsic impedance of the shielding material. Okay, so basically they are related, okay, based on the conductivity, based on the permeability, and also the permeability. Okay, so basically they will determine, okay, what will be the absorption loss. Okay, a material skin depth, Okay, so basically the scheme that is actually depend how deep the wave able to penetrate. Okay, it actually depends on the impedance property. Okay, so I have also discussed what is actually skin depth. Skin depth mainly will happen at a higher frequency. Okay, so in order to have an effective shielding, the material must have a suitable impedance so as to maximize absorption. Okay, so earlier on I talked about reflection. So over here you can see that in order to have an effective shielding, okay, so the material actually need to have certain amount of impedance so as to maximize the absorption, which later on we are going to take a close look on my next video. Item number 5, prevent refraction, okay, which means multiple refraction, okay, under the term B here. Okay, so if the shield impedance is not properly chosen, okay, EM wave can reflect multiple times inside the shield, reducing effectiveness. Okay, so this is what it means here. So if you still remember, we can have multiple refraction inside the shield. Okay, so basically this is what it meant under the so-called item number 5. Okay, so how we can actually prevent a lot of refraction here. So therefore, the shield impedance, okay, we must be proper design. If not, multiple refraction can actually occur. Okay, so this will reduce the effectiveness of the EMC shield. Okay, so therefore, knowing the medium impedance actually help design layer shield. Okay, so whether is it more conductivity, whether against the magnetic layer, so as to minimize this effect. Okay, so let's do a quick conclusion. Okay, the characteristics impedance of the medium, okay, and also the wave impedance of the noise source actually will determine, okay, so basically in short, we need to understand these two impedance, the characteristics impedance of the medium, and we also going to understand the wave impedance. Okay, so basically the wave impedance carry the noise source, okay, because the wave impedance actually carry the noise source and then they hit the so-called surface of the medium that we actually use for EMC shielding. Okay, so basically these two will determine how much energy will be reflected off the shield. Okay, so in short, the higher mismatch between characteristics impedance and wave impedance, the more energy will be reflected off the shield. Okay, so this key difference also will determine the amount of energy that is actually absorbed inside the shield. Last but not least, whether this so-called shielding, whether they were resonant or there will be a leak, this is also very important. Okay, so thus EMC shielding design require impedance analyze so as to ensure optimum reflection loss, absorption loss, and overall attenuation of the unwanted EM wave. Okay, so basically this is what I meant earlier on. Okay, we need to take a closer look on the characteristics impedance of the medium and also the wave impedance so as to proper design EMC shielding. Okay, so in order to have a good EMC shielding, we need to consider the reflection loss, the absorption loss, and also the multiple reflection loss. This will in result the overall attenuation of the unwanted EM wave. Okay, so before I continue, guys, again, if you have learned something from this video, urge you to help me by pressing the like button. When more you guys actually have to press the like button, okay, this video will have a better chances to reach up to a larger audience. So guys, help me press the like button now. Again, if you have learned something and you are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Okay, so this is the equation that I mentioned earlier on. So this is the equation that we actually calculate the characteristics impedance of the medium that we actually use to construct the EMC shielding. Okay, so basically this is the equation. Okay, so let's say, okay, we meet the EMC shield. Okay, we use the insulator to meet the EMC shield. So once this is a insulator, okay, so this is the conductivity. Okay, we know that for any insulator, the conductivity will be a very, very small number. So therefore, this number will be many, many times bigger than this. Okay, so this is actually from this equation here. Like I mentioned, if we use this insulator, this will be a very, very small number. So therefore, this number, okay, will be many, many times bigger than this conductivity, and therefore, the outcome of this characteristics impedance of the medium will be by this equation. And then if we cancel everything, this will be the characteristics impedance, okay, for a insulator. Okay, so basically actually you don't really need to calculate. Okay, so you know that okay, in order to have a good refraction, okay, we need to have a good conductor material. Any insulator, they may not be effective for refraction. Okay, so let me just explain this in order to make this discussion complete here. So basically, you can see over here, okay, you can see that the difference between permeability and the dielectric constant. Okay, basically, this is what I have shown it to you earlier on. So if this number divided by this number, okay, so basically you can see that you actually outcome to have a very high impedance. Okay, so basically if we take this -7, okay, minus 12, it's still considered a very big number. So therefore my so-called characteristics impedance of the medium will be high. So again, if this is high, okay, when this is electric field, this is also high. So it may not be appropriate to attenuate away the electric field because of this. Okay, but like I mentioned earlier on, okay, basically it makes sense. Any insulator, okay, it don't have any reflection property, or maybe I should say that it don't have a desired reflection property. So hence, okay, we will not use insulator, okay, as a EMC shield. We will use a good conducting material as a EMC shield. Okay, so basically this is what I mean. So therefore, the insulator cannot be used as a shield, as you can see from here, because the mismatch is not a lot. Both are considered high impedance. So therefore, they don't have a lot of mismatch. And because of this, we conclude that insulator cannot be used as shielding. Next, okay, so next, okay, I'm going to explain when we actually use a good conductor. Okay, so when we actually use a good conductor, okay, which is the conductivity will be a very significant number. So over here, you can see that this number will be bigger than this term here. So overall, this term here will be just the conductivity. And again, by looking at the equation here, okay, so this thing divided by this, okay, so basically this thing divided by this, okay, so which means that, okay, this thing can be a very low impedance, okay, for the characteristics impedance of the medium. Okay, so if you take this thing, which is already very small, divided by also a huge number, okay, so therefore this characteristics impedance of the medium will become a very small number. And again, from here, you can see that, okay, so if it's going to be dominated by electric field, okay, so therefore my wave impedance will be a big number. So the big number, okay, going to have a huge mismatch with the characteristics impedance of the medium, which having a low impedance. So therefore, okay, for a good conductor material, it will be very effective for refraction. Okay, so basically in short, the characteristics impedance of free space will be equal to 377 ohm, which again, I have already discussed this. But over here, you can see that, okay, when we actually want to do EMC shielding, we need to use good conductor. When we actually has a good conductor, we are going to have a highly mismatch between wave impedance and the characteristics impedance of the medium. So therefore, this EMC shielding will be very effective. Okay, so next, okay, so I just want to so-called make this easier. Okay, so to compute my characteristics impedance of the medium. Okay, so basically this J term I just removed. This W is actually equals to 2 pi F. So this mu R here, basically you can see here, and also the conductivity here. So everything I put, those I know, I put it on the left. Those that I'm not sure, I put it on the right. So from here, you can see that I can easily calculate my characteristics impedance of the shoe. Okay, so as long as I know these two terms, okay, so typically, okay, for the material, you will be able to know the relative conductivity with respect to copper. Okay, you can see that copper is equal to 1. And we also able to know the permeability. So again, all these number, if you are able to substitute into this equation, you will be able to compute the characteristics impedance of the shielding. And therefore, from there, you will be able to know whether this so-called shielding is effective or not. Keep this in mind. Okay, we need to have a high mismatch between the characteristics impedance of the medium versus the wave impedance, okay, in order for this EMC shielding to be effective. Okay, so basically with this, I like to end my discussion. Okay, please help to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.